নেক্সট প্রবলেম, আবার একটি ডিফারেনশিয়াল ইকুয়েশনের জন্য আমরা ক্যানোনিক্যাল ফর্মস বার করব। তো আবার আমরা এটার জন্য বি স্কোয়ার মাইনাস 4ac ক্যালকুলেট করি, and that is equal to 4. So it's always greater than 0, so the PDE is hyperbolic everywhere, and so we find the characteristics. Well, so what we write, integrating them, we suppose this to be say xylem of xy, and this is eta of xy. So we will now convert our differential equation from one to another, and we have so this is sine square minus 1, so we have actually minus 2 sine square x. আর minus 1 যে টার্মটা, that will convert to minus 2, so ultimately we have equal to minus 4 here, because the sine square plus cos square, that is equal to 1, and that is again multiplied with minus 2, and c bar, d bar, e bar, f bar and g bar all are equal to 0. So our differential equation is now converting to this is equal to 0. Now solving that, we know we have two different arbitrary functions, and they looks like say we are first integrating with respect to eta, then that will be a function of xi, arbitrary function of xi, and again integrating we will have the integration of this function, so say that is equal to f of xi, and another integrating the arbitrary function of integration which is with the argument eta. So ultimately we can write our solution to be uxy is equal to f of y minus x minus cos x plus g of y plus x minus cos x. So this is the solution. Next problem, Now we see b square minus 4ac is equal to minus 4x. So this is this is of mixed type actually, see, because this is depending on x. Now as we have said already, x is not equal to 0, so this is not of a type of parabolic. But whenever x is less than 0, we have hyperbolic, and when x is greater than 0, we have elliptic. So we will solve this problem in two distinct planes. Now x less than 0, that is one half plane, right? See, this is like whenever you are taking, this is x o x dashed and y o y dashed, then x is less than 0 is this half of the plane, na? And this half of the plane, this is x is greater than 0. So first we will choose for x less than 0 half plane. Case 1. There we see that dy dx will be this is minus of minus x, and another dy dx is only root over of minus x. Mind it, x is a negative number here. So on integration we will have y is equal to 2 by 3 minus x to the power 3 by 2 c1, and y is equal to 2 by 3 minus x to the power, and here a minus, we have a 3 by 2 plus c2, and from there we can write our xy is equal to 3 by 2 integrating y minus x cube, that is equal to c1, and from there eta xy is given as 3 by 2 y plus minus root x 3 c2. Okay, now these are actually, these are cubic parabolas, and when if you see that this is in a structure which is in cubes, but if you square in the both sides, neglecting this cube, that looks like a parabola, and as this is cube, we call it a cubic parabola. So we will convert the whole system in its canonical form as a bar. Now it calculate that, and that will be 9 over 4x is equal to 0, b bar is equal to 9x, c bar is equal to 0, d bar is equal to minus 3 by 4 minus x to the power minus 1 by 2, and the same is equal to minus of e bar. F bar is equal to g bar is equal to 0. So the required canonical equation is now 9x u xi eta 3 by 4 minus x minus 1 by 2 u eta 3 by 4 minus x minus 1 by 2 u eta is equal to 0. That is, simplifying, we can write this is equal to 1 over 6 eta xi minus eta u xi minus u eta. Now this is the solution if we take a hyperbolic case. Now if we take the half plane x is greater than 0, this half plane, for that what we get, that dy dx is equal to I root x dy dx is equal to minus I root x. And so what we find that xyln xy is actually is equal to 3 by 2 y minus I root x cube, and eta xy is equal to 3 by 2 y plus I root x cube. Now to remove this ith part, we write it like alpha is another parameter which is equal to 3 by 2 y, and beta is another parameter which is equal to this, and we will convert the whole system and we will find that u alpha alpha plus u beta beta 1 over 3 beta u beta is equal to 0. So mind it, whenever even you are going to find out which kind of differential equation is given, you have to check whether that b square minus 4ac term is depending on some non-constant parameters or not. If that is depending on some constant, and you can find out directly the value of that constant, and you can say this discriminant is positive or negative or 0, then fine. But if not, if you get a combination of some parameters, you have to distinguish or partitionize your xy plane into different parts according as the discriminant's value is 0, minus or positive. So first look at that, which value is obtained, and then only take decision and proceed with that particular formula. Next day we will do some problems regarding these canonical problems, and then we will move on the 8th day towards the adjoint operators, etc.